Ladies and gentlemen, please welcome Vice President of Product Management, Fielder Hiss.
Good morning, everyone, and welcome to the second day of SolidWorks World 2013. Did everybody have a great time yesterday? I think we had a great general session to kick the day off. What did everyone think of the engineering team on the Red Bull Stratus project? That's pretty cool, pretty amazing stuff, right? I think we got our first taste a little bit yesterday from Bernard of what 3D experience is going to mean to the SolidWorks community, and also look at our first new product, SolidWorks Mechanical Conceptual. So I hope you're as excited as we are as we move forward with these ventures. Now today, what we're going to do is focus on recognizing much more our users, as well as take a look at some cool customers. Did everyone enjoy themselves last night in the partner pavilion at the reception with hundreds of partners and a lot of people to engage with? I think it was a great event. And the partners are a big part of our community. They're a big part of what makes us successful. The partner community helps us deliver on our great user experience, but they also help us and help you spur innovation and creativity on the design side. Now, in the past year, we made some amazing progress in optimizing the SolidWorks experience and performance in working with one of our key partners, Intel. Let's take a quick look at a little bit of what we've done.
SolidWorks and Intel share a passion about constantly improving performance and delivering exceptional user experiences.
You know, for Intel and SolidWorks, I believe we got it right when we focused on the end user experience for professionals. And we developed it all the way from what I would say is basic computer-aided design using Intel high definition P4000 integrated graphics, all the way to working very closely with SolidWorks on enhancing their simulation software to take full advantage of Intel's multi-core and Xeon designs.
One of the challenges we've always faced was the speeds of rewrite from traditional hard disks. Over the past year, we've been working very closely with Intel, using and testing their solid-state drives in our labs. The performance gains that we saw were so immediate and significant that we not only recommend the SSDs for our users, but we also made the SSDs a part of the standard R&D configuration. We worked with Intel to maximize performance on Xeon workstations with not just 4 or 8 cores, but up to 32 cores and beyond, and best utilize the high-end Xeon CPUs. Complex simulations that took days to solve have been reduced to hours, and it has become faster and easier to create entire photo-rendered animations.
What if you could do twice as many simulations, twice as much scenario analysis, collaborate with twice as much productivity than you could before? You know, Seymour Cray, which I would consider probably the best computer architect of his time, said it pretty simply. He said, the trick is to build a fast system. I know that sounds a little overly simplistic, but what he meant by that was the whole is greater than the sum of the individual pieces. You know, when systems can act as fast as you can think, I think truly amazing things can happen.
So to share a little bit more about what SolidWorks and Intel have been doing together, please join me in welcoming to stage Frank Soki from Intel. Frank, come on up. Thanks for doing this. Thanks for joining us.
Absolutely. Wow. Fielder, thanks for that kind introduction. First of all, I'm actually really jazzed to be here. Let me tell you why. I know SolidWorks has been going on for 15 years, but in my 31 years at Intel, this would be my first SolidWorks World. So please tell me, who's been here, this is their first time? Okay, oh good, I'm in good company, excellent. The other reason I'm jazzed is because we're seeing an awful lot about technology here and what technology is doing to actually bring the future to us now. And that's the other thing, I'm gonna always be jazzed by future possibilities and what tools we have now that are bringing the future to us. The other reason is the video you saw. It's been Intel's privilege to work with SolidWorks on advancing technology, advancing the software capabilities, and helping you to be more productive and more innovative. So the first thing we did was listen to you. We had to listen to what your needs were and what you valued most, solving your problems. Otherwise, we would not be able to deliver the best professional user experience. And the reason I say professional user experience is because you are professionals using professional SolidWorks software. There's all kinds of experiences we can go after with technology, consumer experiences, but this is focused on the professional experience. When we know what your issues were and your needs were, SolidWorks software engineers and Intel software engineers work closely together to make sure we could implement solutions that would benefit that user experience. So we learned what was the right kind of tool capability that you needed, right type of platform capability you needed to do your job. So what this is really about is the user. Design for professionals. Now, we had conversations with professionals like yourselves, but some of you were using desktops. And so we're really interested in what the user experience was like for you using professional applications like SolidWorks on a desktop platform. And it turns out some of you were disappointed. And part of me was a little surprised, but part of me was not too surprised. What was happening was, as we had that conversation, it turned out that if those desktop users were just using basic CAD, they were kind of getting an okay experience. But what they were really doing was you were selling them suites of applications. They were doing layout, simulation, design, collaborating, and those platforms were just not delivering the experience that they needed. So we asked, well, why did you have a desktop? We ended up talking to their IT department and said, we know you build for the general population, but when you realize the user experience that your professionals have, you're buying professional software, here's what's going on with them. And as a result, the few IT companies we talked to in those specific use cases turned to dual-socket Xeon-based workstation designs to help them collaborate. So one size does not fit all, especially for professionals like yourself. So it comes down to, are you on the left or are you on the right? Do you play college ball or are you an NBA professional? Do you use PowerPoint to do your designs or do you use SolidWorks? Are you consumer or are you professional? Do you use a core desktop or do you use a real Xeon-based workstation? So having the right professional tools can make all the difference to the user experience, and working to make sure that the hardware and software elements are worked together to deliver that professional experience is what's interesting to us. And that's the work we've been doing over the last year with SolidWorks. Very happy to have been doing that. So remember, the right tools can accelerate your ability to innovate, and innovate quickly, because nobody's spending time sitting around waiting as the competition keeps moving forward. By investing in the right hardware and software, you can actually increase your productivity, you can 2x your performance, you can 2x the scenario analysis, and you can be a lot more productive when you're collaborating with your peers. So I'm going to do a simple message here is, look at the right type of tool for what you're doing. Yes, we make processors. So I'll start with the processor example. If you're just doing basic CAD, maybe a 4 to 6 core Xeon-based workstation is what you need. But if you're doing simulation and photorealistic design, and you heard the theme 3D and realism, right, is demanded by a lot more of the applications, then what you're looking at is a dual-core, dual-socket Xeon-based design with 16 cores. Now, I've oversimplified that because of the processor, but to really experience the benefit for a professional user experience, there are other technology elements you have to consider. You have to take a look at performance impacts because of memory, because of SSDs that you saw us talk about earlier, storage, graphics, operating system, the applications, and have they been certified on the platform you're using, and do they have the performance drivers behind them? So it is a total package that you're looking at, not just one element. So before I leave the main stage here, I'm going to ask you for a favor. Go take a look at what Intel and SolidWorks have been doing for the past year. You'll see some of this in our partner booths and my customers' booths. Please go see HP, Lenovo, Dell, and Box. They will show you the user experience you get on a real workstation versus a desktop design. Go see what a dual-socket Xeon-based workstation can do with SSDs in it. And finally, if you want to see a sneak peek of where we're headed, I think at 4 o'clock today, making the most out of SolidWorks will give you an idea of where we're going. So I want to thank you for making my first SolidWorks experience a good experience. And I'm looking forward to meeting more of you as I stay here. Thank you very much.
Frank, here's a
token of our appreciation,
Well,
we thank the support we've always gotten from Intel.
It's been great, and I'm looking forward to 13. It's going to be even better. Thanks.
We're excited. Thank you very much. Now, next, we want to turn a little bit of our attention to a special group inside of our user community, and this is our beta testers. Each and every year, for every release of SolidWorks, we have a beta program that's really about taking the work that we do internally in the QA process and allowing customers to really test their designs, test their environments, because the permutations are endless, and it really helps us delivering the high performance and high quality product that we focus on each and every year. As a part of the beta program, it's important that we get people excited, and we've always had a contest to really drive that competitive spirit and get things going. Well, with SolidWorks 2013, we had our biggest beta program ever. We had more than 4,000 user activations of software during this year's beta program. Globally around the world, we did on-site events to allow customers to come in and work with our development in QA and bring their data sets and test in pre-set up and pre-specified environments. They were hugely successful. And overall, we had extremely positive feedback throughout the beta program. So what I'd like to do now is recognize our winners from the SolidWorks 2013 beta contest. I'm first going to start with the Reseller Award winners. In the SolidWorks overall category, please join me in congratulating Michael Maylov. In our SolidWorks simulation category, please join me in congratulating Andre Almeski. And in our enterprise PDM category, please join me in congratulating Charlie Saint. Now, what's interesting on the customer side, and those of you who may follow a little bit of American horse racing, you know we almost had a triple crown winner this year. In baseball, we have a triple crown as well, and we actually had our first winner in over 30 years. Well, I'm excited to say that we actually have our first SolidWorks triple crown winner. We had a user win all 3 categories this year. So please join me in congratulating Masanabu Higashino as our winner of our CAD simulation and data management. So, I'd like to thank everyone in our reseller community, our partner community, and our customer community who participates in our beta program. It is one of the largest in the industry, and we feel it's something that pays dividends. It's extremely important for us, and we thank all of you for your participation and continued support in that program. Now, SolidWorks World is a great example of the global community coming together. But really, it's 4 days. We spend 4 days together. Everyone has a lot of fun, sometimes too much fun, but it's a lot of sharing, a lot of passion, you know, a lot of excitement at the end of the day. But really, when everyone leaves here, that's where the local community takes over. That's where the passion is really derived. That's where there's so much connectivity locally throughout the year. From Austin, Texas, to Bangalore, India, the SolidWorks User Group Network serves users in over 29 countries now. To talk a little bit about our local user communities, please join me in welcoming to the stage Richard Doyle. Richard.
Thank you, Fielder. Hi, everybody. You know, it was 15 years ago this month, from a stage very similar to this, that I first heard the phrase the SolidWorks community. Now, back then, I wasn't really sure what I was hearing that day, but it really didn't take me long to figure it out. The SolidWorks community was people. And once I got really involved in the community, I found out that these were people I could really relate to. They were just like me. Now, you know, back then, 1999, 2000, the SolidWorks community consisted of a couple of dozen user groups, a few hundred people at a place called comp.cad.solidworks. And today it's exploded. 2 million users, over 100,000 people participating in our forums, hundreds of resellers, dozens of bloggers, and my personal favorite number, 232 SolidWorks user group chapters worldwide. So, and I get asked, I get asked, what's the secret behind the SolidWorks user group network? And I proudly say, it's no secret, it's our people. It's the people that take time away from their jobs and their families to attend user group meetings in the evening. Sure, they're there to learn, but they're also there to be with fellow SolidWorks users. Again, people just like them. They sit, they eat, they share stories, they become friends. Some of them even become more than friends. And it starts with these people right over here. Our user group leaders and our SWGN committee members, dedicated, passionate, tireless. They give freely of their own time to provide the opportunities that I've been talking about to the rest of you out there. I want you to recognize our user group leaders and our SWGN committee with a huge round of applause, please. Now, each year, the SolidWorks User Group Network recognizes outstanding service to the community. Our Michelle Pillars Award is presented in memory of one of the original SWGN founders, Michelle Pillar. And it's presented to the person that embodies her passion for the SolidWorks User Group Network and the SolidWorks community as a whole. This year's winner, I'm really happy to announce, is a longtime member of our community, a SolidWorks User Group leader, one of our top forum participants, and owner-operator of Render Bay LLC, one of the first render farms dedicated to SolidWorks users and Moto users out there. Please congratulate Anna Wood. Now, a great user group is filled with passionate members, members that participate in the community as a whole, a fantastic leadership board that, again, participates in our user group network and our SolidWorks community. Each year, one group rises to the top, honored for their leadership and their participation. It's a group that has consistent attendance, consistent meetings, always there for their members. And they share that same kind of passion that all of us share for the SolidWorks community. So I'd like you to start spreading the news, because the user group of the year this year is awarded to the SolidWorks User Group of New York City. Matt Rohr. Congratulations, Matt. Our final award today is being presented in honor, I came prepared for this, folks, one of the finest people I've ever had the pleasure to know. Lots of you out here know him. Wayne Tiffany was a teacher, a mentor, an innovator, and a dear, dear friend of mine. His passion for SolidWorks was unlimited, and his work with the development team and the product definition team is responsible for a lot of the enhancements and fixes that you guys see in the software each and every day. But first and foremost, Wayne was a user group leader. And to commemorate his passion and his history with the SolidWorks community, we're going to be proud to present this award from now on in his name. To help me out a little bit, we've got two very special guests with us. Please welcome Wayne's sons, Michael and Josh. Take them a long time for all of them to get on their feet. So, Josh, Michael, welcome to SolidWorks World.
Thank you.
Thank you.
You know, when we first spoke last fall, you said you guys wanted to come down here to SolidWorks World and get a feel for what this event was, what it meant to your dad, and what your dad did for SolidWorks and the SolidWorks community. And I know you wanted to talk to as many people out here as you could and hear stories about your dad and learn from these folks why he was so special to this community. Why don't you tell these people what you've learned this week?
Well, I've learned a lot. First, I've learned what SolidWorks World really is. It's not just a convention, or just a nerd convention, as our family would call it, but it's so much more. It's 4,500 friends who are geographically displaced, coming back together to teach each other and to have a fantastic time with each other. And Dad was one of those friends. He loved coming every year. Another thing I learned was some things that I didn't know about Dad. I didn't know that when he came here, well, his friend Joe shared with us that when he came here, he was so passionate and so energetic about SolidWorks, about the users, and about the user groups as Richard. And he's pretty energetic. And he loved coming here every year. He, like many of you, he waited the rest of the year to come to SolidWorks World. When SolidWorks World 2012 was over, he was waiting the rest of the year for SolidWorks World 2013. He loved it so much. I never knew why, but here I learned why he loved it so much. He didn't come here just to hang out, but he came here to learn and to teach whenever and however he could. As many as you know, he loved helping people and he loved learning from them. And I think more importantly, he came to spend time with some of his closest friends, friends that he might have even miss him as much as I do. And some of those friends, like Richard, Tom, Joe, Ann, and Phil, and so many more, have taught us so many stories. I loved hearing every one of them. And with every new person that I meet, I realize what an abundant legacy he's left. A legacy that I hope to have someday. So thank you. Thank you so much for having us. And thank you so much for honoring him.
And what I've really learned is just the impact that one person can have on everyone. There's 4,500 people here who all knew him and loved him as much as we did, and we can't say thank you enough for having us here. He really made a big difference in our lives, and I know he made a difference in all of your lives as well. Just learning everything there is to know and just how helpful he was, and it's really made a huge difference to myself and even in my own career. I know he would always stop and help anybody that needed help fixing their computer or their car or their TV, or even if they just needed some advice. He was always there and always willing. And even in my own career, I try and make sure I'm always available and happy to help anybody who needs it. And now I see why he did that. It's the immense satisfaction that you get from that you just have from knowing you've made someone's day just a little bit easier or a little bit less confusing or just a little bit better. And I know he'd be so happy to see us all here, and he'd be happy to show us around to all his favorite sessions and meet with all his 4,500 of his favorite people, and just to even go exploring in some of the less restricted areas of the convention center. And we just can't say thank you enough for having us here and letting us come up here and talk and meet with all of you and just hear all the stories that everyone has to share. And we just can't say thank you enough for all the posts and the forums and the Caring Bridge site. And our families read that and reread that and then reread it again, because it just means so much to us to have all the support behind us. And we just want to say thank you to everyone that's showed us around and that's taken us in and helped us experience SolidWorks World through his eyes. So thank you.
So you guys know that not every one of these 4,500 people knew your dad personally, right? But everybody in this room is going to benefit in one way or another from Wayne's knowledge, from his experience, through his online forum postings, from the presentations that are still available to download and will continue to be available to download from now on. And we are very pleased and very honored to be able to present this award in your father's name, like I said, from now on. So why don't you guys go ahead and announce the winner while I run over here and pick up the award.
So, in honor of Wayne Tiffany, the SolidWorks User Group Leader of the Year is Peter Fisher.
Thanks, guys. Anna, Peter, Matt, congratulations to our winners. The rest of you, get involved with this community. If you're not already involved, if you're not going to user group meetings or attending our Swag and Summit events, you guys are missing some pretty special stuff. So get out there, get involved, start learning more about SolidWorks. I hope I'll see you. I'm going to be out there this year. I hope to see you at a user group meeting or a Swag and Summit event sometime in 2013. Thanks, everybody.
Richard, thanks a lot. Everything that the user group community does and continues to do locally is just outstanding. They're some of the funnest things for SolidWorks employees to attend every year. And Peter, congratulations. You're actually the first person to receive catcalls at SolidWorks World that I've ever heard. So great work. So our next partner supports those who do. To learn a little more, please join me in welcoming Rob Herman from Lenovo. Rob, come on up.
Hey, thanks, Fielder, and good morning, everyone. It's a pleasure to be here, and it's an honor to be a platinum sponsor for SolidWorks World, so thank you for having me. I got to add like 30 seconds to this because that's a tough act to follow. I mean, here I am up here about to talk to you about technology, and we have this very personal story. And, you know, I've been in the technology business for over 20 years. And, you know, I've always said that it's a people business. And it really does start with you, like Frank said. You know, it's the innovation and the sharing of knowledge that you all do that makes this business go. So really, you know, you really should be patting yourself on the back for what a great community you have here. So I'm honored to be up here today. So, you know, speaking of people, I did want to start with something that I heard many years ago, and that is that there's four kinds of people in the world. Those that watch things happen, those that wonder what happened, those to whom things happen, and those who make things happen. And it's clear from what I've seen over the last 2 days and you know, speaking with many of you in our booth and seeing some of the demonstrations that you all make things happen. You're the doers. And at Lenovo, we have a lot of respect and admiration for the doers, for those who do. And that's what our mission is about, is to provide you technology that help you do your work every day. So today I'd like to talk to you more about what we can do together. So what I want to start with is kind of frame the discussion around some things that we talk about at Lenovo. And basically, you know, the realities of the past and the promise of the future really help us, you know, to address the opportunities of today and tomorrow. And, you know, there's three realities that, you know, I think we need to consider. First, that tools make us better thinkers. You think about how tools, you know, really speed up, free us up from routine tasks and help us to have more time to consider higher order problems. So tools make us better thinkers. Second, the world is changing, and the speed at which we respond to, or better yet, initiate change is critical, especially in the face of increasing complexity. And third, the cloud is here to help. The cloud is giving you easier access and more access to resources, tools, and collaborative environments where you can learn more and add more value to your designs. So with that backdrop, I give you this proposal. The more real-time information we have available to us, and the faster and the more we can consider more viable opportunities, the faster we can make better decisions and get to a better design point. And really, that's what doing more is all about. That speeding up your routines, freeing up time to do higher order work, and having more options available to you. So you even look at an example like Fielder talked about mechanical conceptual yesterday, and he talked about it being instinctive, and that it really anticipates what you do with your design going forward. And that's an important thing because it really helps speed up your work. It speeds up your routines. But you also need a hardware to go drive that. You need a balanced system to go drive that. You need faster performance to go drive that faster task work. So what gets us to doing more? It's about having a balanced system. Okay, so I'm a hardware guy, and I'm going to be talking to you about hardware balance, but it really starts with the software intent, the design intent, and the software that you use. So as a designer, you really need to determine how deep you're willing to go with your design. And at the speed, at the speed the world moves today, you really need to clear out the unknowns at the concept phase fast, and then get ready to show a more realistic product as you get closer to completion. So you need a balanced system. You need to investigate where you're going to stress your system from a CPU standpoint, from a data I/O standpoint, your hard drives, as well as your graphics. And then finally, memory. Everybody knows that if you don't have enough memory, you're really going to cut your productivity nearly in half just waiting for things to process. And then finally, really push the boundaries of the extreme functions that you're doing on your work. Are you going to be doing hardcore simulations or realistic visualization? If so, you really need to push for the maximum performance capabilities on your system. And so, the formula is simple on this slide. SolidWorks software plus robust hardware plus the 3D experience offered by Dassault gives you a competitive advantage. SolidWorks software and the 3D experience can get you from concept to reality faster. And the cloud means easier access to information, tools, and resources. So what does this mean for you? Well, as Frank was saying, this formula means potential for twice the simulation throughput and nearly double the models to explore. And this really provides two benefits. One is optionality. You've got more options to explore to get to the best design possible. And speed to market. Getting your better product to market faster than the competition means that you win. So overall, it's a competitive advantage for you. So finally, just to jump off the slide, no, this is not Felix Baumgartner from the Red Bull Extreme Skydiving, but it does, it does bring a thought about that, and I have kind of an analogy to that extreme skydiving. You think about what these guys did, and the backdrop behind it. We've been to space countless numbers of times, and this feat was actually performed above 100,000 feet in 1960, so over 50 years ago. And yet this team really pushed itself to the limits to make sure that they were using the best technology and going to extreme innovation to ensure that the jump was safe and that it was successful, and that they broke Mach 1. Always push yourself to use new technologies, and that's what we really encourage. We'd love for you guys to stop by our booth. We're happy to answer any questions, and we're here to help you solve your problems. So really appreciate the time, and have a great show.
Thank you very much. We appreciate everything.
Thank you.
Thank you very much for your continued support. So, and we thank Lenovo very much for their continued support. This event wouldn't be possible without the partners that you're hearing from today, and we'll hear more from tomorrow. Now I want to shift gears a little bit, and I want to shift gears to talk a little bit more about users and certification. I actually learned a very interesting fact yesterday, and someone shared this number with me, 3.5 million. And I said, well, that's not the number of users in the community, because we learned that was 2 million. You know, it's not the number of educational institutions. There have been 3.5 million questions answered in our certification tests online since the exam has been created. So when you think of all those different numbers, all those different certifications, 3.5 million questions. It's kind of crazy when you think about it. So here to talk a little bit about the past, the present, and the future of our certification program, and I do mean ours. Please join me in welcoming Avelino Ricino and Mike Puckett. Guys, come on up.
Thank you. Thank you, Fielder. So 2013 not only marks the 15th anniversary of SolidWorks World, it also marks the 15th anniversary of the SolidWorks certification program. It was in 1998 that we introduced the Certified SolidWorks Professional exam that most of you probably know or are more familiar with as CSWP. In 2007, we took the leap online and introduced the Virtual Tester online system. This made our exams accessible to everyone worldwide. Today, the Virtual Tester online system manages a database of over 116,000 unique user accounts and over 30 different exams, and averages over 150 testing sessions per day. This has resulted in over 89,000 total reseller and user certifications.
Today we'd like to make an announcement for the upcoming release of our newest certification. This will be the SolidWorks Advanced Drawing Tool certification. For the first time, we'll finally be able to measure the expertise of a user in the SolidWorks drawing environment. Another announcement we'd like to make regarding one of our more recent certifications is the Certified Enterprise PDM Administrator Certification, or CEPA exam. The CEPA exam is going to have a promotion that it will be free until the end of June. So what's the value of these certifications to both the individual and to companies? Well, we'd like to share a couple of examples. The first company that we'd like to talk about is our friends at Quechak Marine. Quechak Marine is a company based in Seattle, Washington, and they're a manufacturer of aluminum vessels. These vessels serve a few different missions: law enforcement, search and rescue, and commercial. Now, they've been using SolidWorks for about 14 years, and this past year they contacted me and they wanted to take advantage of the free tests, free certification tests that are available for all subscription service customers. So to date, they've certified their entire SolidWorks workforce, and they now have 26 CSWAs and 10 CSWPs, so that's administrators and professionals. So they wanted to do this for a few different reasons. Number one, they wanted to gauge the performance of all their SolidWorks users. Number two, they wanted to design additional training that was identified by the exams for the users, just to make them better users in SolidWorks. And then finally, number three, they wanted to recognize their users and give them a sense of pride and accomplishment for using SolidWorks as an everyday engineering tool. So the core and advanced certification exams help them accomplish all of these. And then finally, when Quechak is looking to hire people, they look for SolidWorks certified users, and they prefer them over non-certified applicants.
At the Disneyland Resort in Anaheim, California, the Ride and Show Engineering Group is using SolidWorks to update some of the most iconic rides, such as the Indiana Jones attraction and the Matterhorn bobsleds. These rides must be designed to withstand up to 18 hours of use per day and a service life of over 15 years. The Ride and Show Engineering Group is using SolidWorks certifications to improve their SolidWorks skills and to earn additional SolidWorks certifications. It was in the early 1990s that the Indiana Jones attraction was originally designed using 2D CAD. A few years back, Dave Hertwig, who was the original designer, used SolidWorks to redesign the chassis, axle, motion base, and body to improve the reliability, the maintenance accessibility, and to reduce the maintenance cost. Sheet metal tools inside SolidWorks helped Dave to create the complex body, which has over 400 rivets. The ability to study the motion and the movement of the ride's complex and patented motion-based movement in SolidWorks helped the design team foresee interference issues before production even began. The improvements were such a success that this second generation of vehicles is now traveling over 50,000 miles per year with no major issues. This project is helping Dave work towards earning both his sheet metal certification and advanced simulation certifications this year. This past year, the Matterhorn bobsleds underwent an extensive refurbishment that included all new redesigned ride vehicles that went from a 2-seat tandem configuration to a 3-seat individual seating configuration. Noel Perez, who was the lead designer, used SolidWorks 2009 to stay within the existing ride envelope due to the fact that they were not making any changes to either the track or the mountain. That meant that the existing vehicle clearances had to be maintained, but Noel still had to incorporate all the new design changes that were required into the ride vehicle. So the design configurations that led to the final design for the body, restraints, the chassis and bogies, the grab bars and tow bars were accomplished using a multitude of SolidWorks tools that were first made available in SolidWorks 2009. The extensive and complex surfacing work on this project will no doubt help Noel earn his advanced surfacing certification this year. Besides having a hand in designing some of the most loved and admired attractions in the world, the Ride and Show Engineering Group in Anaheim, including Dave and Noel, hold multiple SolidWorks certifications. So if you'd like to ever apply for a job with these guys, take a look at the job posting behind me. This from the past. Not only is the CSWP required, but I've heard from an inside source that it'll also guarantee you an interview with them. The Disneyland Ride and Show Engineering Group has embraced SolidWorks certifications as a benchmark for the entire team. So how can we best utilize this large community? Well, one way is to make it easier to connect. Today, SolidWorks users that have a SolidWorks certification can choose to be listed in our online directory, but the limitation has always been that only their name, location, and company name is listed online. So today we'd like to announce new functionality that will allow those users that have SolidWorks certifications and who opt to be listed online to add in their LinkedIn account. Once opted in, this will allow users and companies to connect in a way that's easier and more direct. So if you have a SolidWorks certification and you'd like to be listed online and add your LinkedIn profile, visit solidworks.com/CSWP for more information.
So companies who are serious about engineering are serious about SolidWorks certifications. So really to our ever-growing community of SolidWorks certified users, we really, really want to thank you for 15 awesome years. And we're looking for 15 more years as well. Take care. Thank you very much.
Thanks, Mike. Guys, thanks so much. Thanks for continuing to push the limits, expanding the number of exams. I think you're running out of letters, though, in some of those opportunities. They're getting pretty long. Now we want to shift gears a little bit to some cool technology. Our next presenter is actually taking robots to new heights. He's created swarms of agile aerial robots which aid in search and rescue. He's the UPS Foundation Professor at the University of Pennsylvania. Please join me and give a big SolidWorks welcome to Professor Vijay Kumar. Vijay? Thanks for joining us.
Good morning. It's a great pleasure to be here at this conference to tell you about some of the work my students and I are doing in building aerial robots like this. Actually, Rob Herman told you the difference between people who make things happen and people who watch things happen. My students make things happen. I watch them happen. So the robots we build and design are closely related to unmanned aerial vehicles that you see here. But there's 2 or 3 big differences. So these vehicles are not really robots. They're remotely piloted, oftentimes by a crew consisting of many, many operators. They're pilots, they're sensor operators, they're analysts, they're mission coordinators. And these UAVs are big. They weigh thousands of pounds. In contrast, the robots we try to build are something that you can carry in your arms. At most, 1 meter in diameter, at most, a couple of kilos in weight, and they fly indoors. The smallest one that you see here on the top actually weighs a little less than 75 grams. All these robots on the left side are called Quadrotors, and that's because they're helicopters with 4 rotors. So you can imagine if you rotate all motors at some nominal speed, then the lift generated by these rotors compensate for the weight and the robot hovers. On the other hand, if you carefully control these speeds, you can get this robot to roll, pitch, and yaw, and fly in whatever direction you want. The smallest robot that we have, as I said before, weighs a little less than 75 grams, is about 21 centimeters in diameter, and consumes between 10 to 15 watts of power. So robots like this can be used for emergency response applications. Imagine a 911 call in a building like this, and the first responders on the scene are robots. They gather information and provide this information for human rescue workers that might come much later. They can also be used for search and rescue, as you see here. So these are pictures of our robots in Sendai when we did experiments following the earthquake in July 2011. And you can see here the ability of these robots to fly in collapsed buildings and take pictures and send information back again to human rescue workers. You can also use these robots for construction and for transportation. So in the video on the top left, you see robots assembling truss-like elements with magnetic rods forming 3-dimensional structures. This is only a laboratory prototype, but you can imagine bigger robots performing construction tasks on a larger scale. Or even smaller robots, as you see on the bottom right. If you build smaller robots, the payload's going to be smaller. Well, you can get these robots to collaborate to pick up larger payloads. Size does matter. So if you take the characteristic length R of a robot, now I'm allowed to use mathematical symbols here since we're all geeks here. We know that the lift scales as the square of this length. But what also helps us is that the inertia also scales as powers of R. So if you make R smaller, let's say by a factor of 2, the lift drops by a factor of 4, but the mass also drops by a factor of 8, and in fact, the inertia drops by a factor of 32. So when you try to compute the acceleration that you get from scaling down, the linear acceleration actually increases. It goes as 1 over r, and the angular acceleration even more so. It goes as 1 over r squared. So you get 4 times the angular acceleration as you scale down the length by a factor of 2. So this works to our advantage. As we build smaller and smaller robots, those robots become more agile. So what you see in this video is one of our smallest robots doing flips, double flips. The single flip can be performed in half a second, and the robot accelerates from hover position to a maximum angular speed of 2,000 degrees per second in less than 1/4 of a second. So again, all of this is possible because an onboard computer carefully monitors signals from an onboard gyro and accelerometers to stabilize the aircraft to hover. So one of the co-inventors, Daniel Mellinger, throws this robot into the air, and you can see this robot recover no matter what position it's in and return back to him safely. So we want to take robots like this and make them autonomous. So a key issue you really have to deal with is motion planning or path planning. In other words, how do you get from point A to point B? So here's a schematic. On the right side, you see what I've tried to draw here, which is a 12-dimensional picture, which I can't really draw. But what I want to convey to you is this idea that if you look at the dynamics of a robot like this, it's complicated, can be only described in a 12-dimensional space, and further, this space is curved. And the reason it's curved is when you write down the equations of motion, they have all kinds of nonlinearities. What we have to do is plan motions for this in real time. So if you consider the problem of going from point A to point B, and you want to perform all these computations on onboard processors, this is quite hard. So there's a trick that allows us to transform this 12-dimensional space into a flat 4-dimensional space. And in that 4-dimensional space, all you have to worry about is the position x, y, and z, and then the yaw angle. If you can find sufficiently smooth trajectories in this 4-dimensional space, trajectories that avoid obstacles, then it's possible to take that and transform it back to the 12-dimensional space. And this is the trick that our robots use to plan motions in real time. So what I want to show you is some examples of experiments that we have done using this strategy. In the first video you will see is this robot going from point A to point B through an intermediate waypoint C. And here you'll see that the trajectory that's planned is an aggressive trajectory. It starts from a hover position, and you can see the rolling followed by the pitching, which it has to do to stop. Again, in this flat space, it's pretty easy to find these trajectories, but when you transform it back, you get trajectories like this. And this is done autonomously. The feedback is obtained from a motion capture system overhead that provides real-time information 100 times a second. But this planning is done at 20 hertz. So 20 times a second, you can calculate these minimum snap trajectories, which are smooth trajectories that minimize the fourth degree, the fourth derivative of position to find the right paths. Another thing you can do is have them go through obstacles. So in this case, the robot knows precisely where the obstacles are because of the motion capture system, and it plans paths through these obstacles with remarkable precision. And it doesn't matter if these obstacles are moving. As long as it can predict the motion of the obstacle, the robot can plan paths through these obstacles, again, in real time. It gives you a new appreciation of the phrase jumping through hoops, doesn't it? I want to show you another clip where the robot is confronted with a window that's only 3 inches wider than the robot's height. So what you have to do here is take examples of trajectories that you've learned before and sort of stitch them together. So I want you to compare this exercise to what an Olympic diver, for example, has to do when she jumps off a springboard to gain energy and then twists her body into the somersault and then recovers gracefully. And so what this robot does is it starts from a hover position, and then it twists its body to go through this window, and then it recovers. And again, there are these 3 distinct phases that are integrated together, building up momentum, changing orientation, reversing orientation, and then switching back to hover. So again, these trajectories are stitched seamlessly in real time in response to obstacles that are confronted. So I want to switch gears a little bit and talk about one of the limitations of scaling down, which is really this issue of size. And what we really want to do is get lots and lots of robots to collaborate if you want to carry payloads. Now, these payloads might be objects that you want to transport or sensors that you might want to use to map the environment. And cooperation is a fundamental aspect of all of this. And here we've been working with biologists, and this is a video shot by my collaborator Stephen Pratt at Arizona State. Nature offers several examples where groups accomplish tasks that individuals cannot accomplish. So what you see here is a piece of fig that the ants are transporting back to the nest. And if you look at this video, it's quite clear that there's no central ant who's calling the shots, right? The ants do signal each other if they're close to each other, but no ant actually knows how many ants are part of this group. All the coordination is very local. And these examples are not limited just to ants. There are certainly other examples. For example, here you see photographs of 1 million starlings flying in from all over Europe, assembling in Denmark to form these incredible formations. And again, there are 3 things that I'll submit to you that are similar to ants, these birds, and to our robots if we have to make them cooperate. First, they operate just based on local information. It is not possible. There are 4,500 people here. I guarantee you that the person at this extreme doesn't know what the person at the other extreme is doing. So you have to act based on local information. Secondly, you have to act independently. There's no one who's going to tell you exactly what to do in order to accomplish this cooperative task. And then finally, there's got to be this notion of anonymity. What I mean by that is an individual has to be agnostic to who her neighbor is. That's very important if you want to perform a collaborative task. So the ants have no identities. The robots don't care which robot is next to each other. So I want to show you a video that we've just created. This was about 6 months ago, which shows the biggest indoor swarm that we've managed to create. So these are these really small robots that I told you about. There are 20 of these flying in formation. They're all aware of their neighbors. They all solve this problem of going from A to B, but they're told by the human operator to create these formations. And these robots create these formations in a safe way, keeping track of their neighbors. These formations can be 2-dimensional, 3-dimensional. They can change dynamically to go through obstacles. And again, the control has to be very, very precise, as you see in this video, where they traverse a figure-8 pattern. And these robots come within inches of each other, and you can imagine the level of precision that's required because they're buffeted by the aerodynamics of their neighboring vehicles because of the downwash from the rotors. So this is an example where the robots are just creating formations. It makes for a cool video, but what we'd really like to do is to get them to collaborate to carry objects. And so here you see teams of 4 robots carrying payloads that individuals simply could not have carried. Now here there's a disadvantage. You can see if you group many robots together and have them carry one big payload, the overall inertia of the system actually increases and the maneuverability decreases. But what you gain here is, again, the ability to carry larger payloads. And so here you see these robots actually collaborating on identifying a piece of a 2x4 and then figuring out how to grasp it. And these are grippers made out of composites with inlaid fish hooks, which allow you to sort of dig into these 2x4s to pick it up, and they're able to move. The next example I want to show you is an example of construction. So here there are 3 robots that are assembling structures based on blueprints that look roughly like what you see in a Lego instruction booklet. So the robots are told what the pattern needs to look like, the 3-dimensional structure. The robots decide which robot is going to pick up what part and assemble it where. And here you see, fast forward, 3 experiments where the robots essentially build 3 different 3-dimensional structures. Again, the high-level specification is very simple, but the robots make all these decisions on their own in order to satisfy that high-level specification. So in all these videos, one of the things you would have noticed is this network of motion capture cameras. This makes for a very, very special piece of infrastructure. And if these robots have to leave the laboratory and go outside, it's hard to do. And so we've been working on figuring out how to get rid of that infrastructure, how to eliminate the need for that infrastructure. And here's our first attempt to do that. So this robot has 2 pieces of hardware. One is a laser scanner that essentially produces a 2D cloud of points at a 270-degree field of view out to about 30 meters. The second is an off-the-shelf Microsoft Kinect RGB depth camera that is, again, good to between 3 meters to 5 meters out with a 40 degrees field of view. Using both these sensors, the robot can now start distinguishing features in the environment and triangulating of those features. This allows the robot to localize. as I'll show you in this video, where the robot essentially takes off outside a building it's never seen before. It builds this map that you see on the left-hand side, which essentially is a collection of all the features that it sees. And then it's triangulating its position with respect to these features 100 times a second. So those motion capture cameras are gone, but the onboard cameras provide roughly the same information. And the reason I say roughly the same information is because these robots like this, don't have any access to a global coordinate system like GPS or our motion capture camera system. What they have to do is to triangulate with respect to features that they have located, and so they have a relative sense of how fast they're moving. But as you can see here, this robot is completely autonomous. The student who is operating this can only see the video that you see on the left, the map that you see on the left. And based on that, he can essentially command the robot to go inside a building and look for whatever information that might be relevant to the particular mission. And again, you see the camera pictures coming that the robot sees on the top right. That gives you a sense of what is actually visible to the robot, but that information is never relayed back to the human operator. The human operator only sees the robot's internal representation, which is on the bottom left. So we've used robots like this. As I told you, shortly after the earthquake, we went to Fukushima and Sendai, and this is an early experiment we did in one of the collapsed buildings. So this is in collaboration with our collaborators at Tohoku University. They created this ground robot, and the reason our robot is hitching a ride is because it's programmed to be lazy, just like humans. And the reason for that is simple. It's about the limitations of the batteries that we carry. So because we want to extend the mission life, the robot hitches a ride whenever it can. But here you can see it's confronted by this obstacle. The ground robot cannot proceed any further. It releases our aerial robot. The aerial robot goes in over this bookshelf, which is impossible for a human to actually go across, through this buckled doorway, and it's able to recover this three-dimensional information. And it integrates this three-dimensional information with information that the ground robot has, allowing this air-ground collaboration between two very different types of robots. And to just give you a quick idea of a mapping experiment we did, so this is the 7th, 8th, and what remains of the 9th floor of a building in Tohoku University in Sendai. This was, again, done 3 months after the earthquake. And you can see that the robots have collected all this information and integrated it into a map. Now, this map may not be easy for you or I to visualize, but remember that if you wanted more information, you could actually get it from the robots that have access to even more information that you see over here. So one other thing I really wanted to talk about is the ability to bring together aerial robots technology along with music and lights that really lends itself to new art forms. So this is not my work. This is not our lab's work, but my former students who have now established a company, KML Robotics, did this performance at a Saatchi & Saatchi marketing event. So what you see here is 16 of their robots coordinated with laser lights with 16 different actuators, all synchronized perfectly and choreographed to music. So art forms like this are now being enabled by a really cool mix of technology and music. And I think we'll see a lot more of this in the years to come. But next, what I really want to do is to show you the coolest video I have. And it behooves us to show it here, the coolest conference I've been to in my 50 years. This is the James Bond theme song, celebrating 50 years of James Bond. And let's watch 9 Quadrotors playing the theme song. And I'm going to shut up and let you listen. So I'm at one of the largest conferences of, I think this is the largest group of talented designers, and I would be remiss in not pointing out the important role that 3D CAD design tools like SolidWorks play. We use SolidWorks for all our designs, for creating, for modeling. We model. There's more. We use it to model the frame, the motors, the boards, the processors, even the heat sinks, and then finally the cameras. And the reason we want to do this is because we're not only interested in the geometry, but we're also interested in the mass, the distribution, the inertia, and ultimately in understanding dynamic performance. We test different configurations. This one has a larger frame, a camera, and a laser rangefinder. This one is the one that I showed you, the Kinect 3D depth camera, and the cage, which is important because that's the only thing that protects our fingers. We explore 3D printed frames. We try different motors. We model details down to that little switch that you see on the bottom left. We look at accessories, whether we can actually integrate things with our quadrotors, like these grippers. And an important problem that we're working on now is autonomous charging. So what you see on the top left is an autonomous charging station. On the top right is a landing platform. And on the bottom, you see the integration with mobile platforms that eventually can allow these robots to sustain longer missions because they have an autonomous charging station on board a mobile robot that's going to support them as they move along. So model-based design tools, such as SolidWorks, play a key role, I think, in systems integration and development. But a key challenge, to me at least, is the co-design of software and hardware. So whether it be electrical hardware or mechanical hardware, we know that the value added by software is significant. And more importantly, the fraction of the value of a product that you can attribute to software is steadily increasing. This is true even in cars and airplanes, not just in robots. And in all these applications, sometimes it's hard to separate the hardware design from the software design. So I think this is a lot of challenges for people like us, at least 3 challenges. The first challenge, I think, we're already addressing, which is creating the infrastructure for innovation. That's what this conference is all about. Second, a big challenge for robotics, and certainly in all kinds of cyber-physical systems, cars, airplanes, even medical devices, is sort of this co-design of hardware and software. And third, and this may be the hardest challenge for us to address, is really making these tools widely accessible, open architecture platforms and systems. So I think this is a huge opportunity because it really changes the paradigm for innovation. Instead of having 4,500 smart, talented people here, we can now have the whole world working on these problems. And by doing this, we can lower the barrier to entry, we can increase the number of shots on goal, and truly accelerate the rate of innovation. So I think this is the big thing for us going forward in robotics. Thank you.
VJ, thank you so much. Thank you so much. That was outstanding. I thought, you know, just the intelligence of the robots, the ability for them to work together, really just quite amazing, and really ended on a good note, I think. Next, I'd actually like to bring up someone who's been at SolidWorks for many, many years. He's one of our more innovative and creative thinkers. He's worked on projects like eDrawings, our feature expert, our sustainability products. And he's really good at taking complex things and simplifying them for you, our users. So please join me in welcoming to the stage Rick Chen. Rick?
So, biomimicry, okay? It's a term that refers to a really fascinating field where you look to nature to solve really difficult problems. And VJ just showed us some really, really cool stuff around how ants can work together, the flocking of birds. Okay, we're going to talk a little bit more about that. So with that in mind, I want to introduce our next customer. Now, Festo is a company that is based in Stuttgart, Germany, and they have got a worldwide reputation for creating products that are high performance and high quality in the factory automation space. And within Festo, there's a really special group called the Bionic Learning Network. Okay? So I'd like to introduce Elias Knubben, the head of the corporate bionics program at Festo. Up on stage, please welcome him.
Hello.
Hello.
Hello, everybody. Thank you very much. Thanks for the invitation. It's a pleasure for me to be here.
We appreciate you making the trip all the way out here to join us and tell us what you do. Now, Festo, they create products that a lot of you are familiar with. They're things like grippers, actuators, sensors of all different kinds, and they're very practical, very industrial in their nature. Okay? But the work that you do in the Bionic Learning Network it has a different focus. Can you tell us what the group is all about?
Yeah, sure. My name is Elias Knubben. I'm an industrial designer, and I work within Festo, which is a family-owned company for factory and process automation, and we have established in 2006 a group which is called Bionic Learning Network. So we are a very interdisciplinary core team with control engineers, informaticians, designers as well, air and space engineers and so on. And we are working on future concepts, projects which are mainly inspired by nature, because we are searching for intelligent and efficient solutions to improve our projects as well. And to generate innovations, we search for new materials, technologies, new structures, designs together with our network partners.
Okay. All right. So you work in a lot of different areas, right? Very diverse, like you said, surfacing and all sorts of engineering, and it's very challenging, diverse. But can we actually take a lot of that and actually bring it together and talk about some very, very specific projects that you work on? So the first thing I'd like to talk about is the Robotino. Okay.
Yeah. You mentioned the Robotino. Actually, the very special thing on this is this so-called handling assistant, which is inspired by the trunk of an elephant. So in the beginning, we are really very fascinated from this specific kinematic, which is so much different from all the kinematics which we use in industrial robotics nowadays. And the big challenge was to find the technical abstraction to get a really lightweight construction. We found that this could be possible with pneumatic actuators. And we're using this so-called manufacturing selective laser sintering process to manufacture this kind of kinematic. And the challenge here was to optimize the geometry to get enough durability and flexibility at the same time. Besides this you could solve with SolidWorks quite well, using SolidWorks as the designing software. But there are a lot of other very difficult things to do. For example, it's very hard to control this kind of system because we don't have any defined joints like this on the real elephant trunk too. So we had to look to how could we measure the positions and the elongation of the chambers and how to control exactly the compressed air within in the chambers. So we're using piezo valves, and now we are able to control the stiffness quite well of this kinematic. Okay. And this gives us the possibility to use this in non-hazardous human-machine cooperations. So we won the German Future Award for this because we, and also the givers of the award, we think that there's a lot of potential in this kind of very lightweight constructions in terms of service robotics or as assistant systems in factory automation as well.
Oh, okay. No? And now, this product, it's not for industrial applications, right? It's for the educational space?
Yeah, actually the trunk itself, we combined it with our Robotino. Robotino is a robotic platform we sell since years to students and universities so that they can learn how to program. And actually it's a OmniDrive platform, as you can see in the animation, which is able to drive in several directions. We have a Linux PC on it and a lot of electronics. And we combined this with this elephant trunk kinematic, added valves and mini compressors and so. And as you can see in the animation now, we are able to to fill these chambers very precisely with compressed air and to bend and move the structure. And we combined this structure with a so-called fin ray structure. I brought one with me as well. Maybe we get a close-up to this structure, because this is, in my opinion, very interesting as well, because we found this together with our network partners on the tail fin of many fishes. If you have a look at this structure, if the water pressure presses against this structure, the structure bounds in the opposite direction. So this gives many fishes a very efficient paddle. And we found out that we could use this kind of structure for adaptive cripping. So as you can see here, actually it's a very simple piece, but it helps us without any control to grip many things with different shapes. So our customer used this for gripping potatoes and fruits and so, something like this. Yeah?
So this, man.
Yeah.
So if you can actually zoom in once again on this, this again is a great example of what biomimicry is all about. If you look closely, right, this is actually, I was thinking about this last night because I saw this for the first time yesterday. This is kind of like an organic system of 4-bar linkages. And it's such a simple and elegant design. I mean, it's just the kind of thing that we all strive for when we do mechanical engineering. And again, this was something that you found in fish fins, right? It's not something exotic, right? These solutions to problems are available to us everywhere we turn, and you just have to tune in to the right kind of problem. Now, so you said this was done with SLS,
yes.
rapid prototyping.
Yes.
And was this done in one build?
Yes, completely, including the joints. Yeah.
Okay, very cool. I mean, this is where design and manufacturing is going. Okay. So let's talk about the next project, okay? The ExoHand, okay, which is equally cool. Tell us about that.
Okay, the ExoHand actually is an individual customized exoskeleton hand, which is also generative manufactured for a perfect fit. And therefore, we made a 3D scan of my hand, imported it into SolidWorks, and the challenge now was in the design process to realize all physiological degrees of freedom as the human counterpart has. So we're using 8 double-acting pneumatic cylinders, position sensors, pressure sensors as well, and we are able to move the hand actively and to increase the forces of the fingers. So we see that there are several applications possible in the future, for example, in the field of service robotic, or to support elderly people in the production and assembling lines, for example, or as a medical device as well. Yeah, we also implemented force feedback. I can maybe, yeah, you can see this on this animation for a safe remote control in dangerous environments, for example. And therefore, we are able to use this software twice, once as an interface hand in combination with a glove, and also in combination with a silicon hand as an artificial robotic hand, which we mount on a robot. So we're using a 3D measuring system to get the position of my hand, and webcams to orientate. And the task, as you can see here, is to grip several items with different shapes and to place them into a box with an adequate cutout. So what we really need to manage this task is to measure the forces which do result while gripping these items and to transfer them back to my interface hand. So me as an operator, I really get the sensation of feeling the shape of the remote control object.
Awesome. So products like this, and like the ExoHand in particular, is this something we're going to see in the market in the not too distant future? Or why do you do things like this?
Yeah, okay. Up to now, it's a future concept. Within our department, we try to look into future and figure out which topics are relevant in the future for our customers in the field of industrial automation. So we think because of the demographical change, for example, we will have, we will need assistance systems to make the work for these elderly people more human, for example. So in terms of assisting system, it's a future concept. But Nowadays, we are in a cooperation with the Center of Integrative Neuroscience, and we use this already as a medical device, as you can see on the left side here. In combination with a brain-computer interface, we are able to measure the brain activity of stroke patients, for example, which have a damaged connection from their brain to their hand. So combining this interface with an exo hand, we are able in a closed loop training session to regenerate this damaged connection again. And this is what we're really working on today with these cooperation partners.
I mean, that's awesome. I mean, the work that you're doing, it's kind of, that is how innovation happens, right? It's this intersection, right, of all these different activities and different needs that don't normally come together. So, and that's a great example of this. Now, for Festo to kind of do this kind of work is very, very forward-thinking, right? And so when you start projects, is it something where, you know, you have a very, very specific industrial need in mind and say, okay, let's start looking around in nature to find a potential solution? Or is it something where you see something in nature and say, wow, I wonder if we can apply that to industrial products? How do projects start?
Actually, it's both. So we have a top-down and a bottom-up process. So we're searching for technical solutions of unsolved problems from our customers. So we are in discussion with them on our fairs, for example. We present all these demonstrators always in April, also this year again. And then we discuss all these future concepts with our customers. And quite often they came to us and they, oh, we have this problem and we don't know how we could solve this in an efficient or intelligent way, for example. So we have biologists in our group as well, and then we really look into nature, searching for the role model, the biological role model, which does this which solves these tasks very efficient. But on the other side, nature is ideally adapted to its surroundings throughout millions of years of evolution. And there's such a big diversity of very cool solutions. So we look also in nature and getting fascinated from elephant trunks or fish fins or something like this. And we try to copy this and learn from this to improve our projects, which we sell today and tomorrow and hopefully in years.
Yeah, I think it's fantastic. I mean, when you think about it, right, nature is this like almost infinite test tube, right? And it's been doing trial and effort for a few 100 million years. I mean, I would kill for a design budget like that, right? So there's all these lessons, all these problems that have been solved, and we just have to kind of tune into the right things. Is that a fair assessment? Awesome, awesome. So now your inspiration obviously comes from almost anywhere in nature. And so how do birds, for example, inspire the work that you do?
Yeah, so we were very fascinated from flying objects, as Mr. Kumar probably as well. So humans are very fascinated from flying objects since hundreds of years. And in the very beginning, we started with helium-filled objects, but we always tried to drive these objects with flapping wing mechanisms. We didn't want to use these propulsion drives, but we did a lot of research. How can we actuate the wing mechanisms, the flapping wing mechanisms? And in the beginning, we made this air ray, which also had this fin ray structure I demonstrated already in the wings to bend the wings very smoothly. We had another demonstrator. It was inspired by the penguins, which have a very perfect shape for aerodynamic shape. And we used passive wings, pedals, like you can see here. In this case, we also tried to figure out what we would need for autonomous behavior, swarm behavior. So we had several ultrasonic sensors and we were able to fly with 6 of these flying objects, but not as fast as yours do, because the helium objects are quite slow. So we always worked on to develop these flapping mechanisms further on to get more efficiency and to improve also the lightweight designs of the flying objects. And we came up in 2011 with this so-called smart bird, which is inspired by a real bird. It really flies like a bird, and it doesn't need any helium anymore. So it flies just by his own power, actually. And So let me explain how it works, actually. In the center of the body, there's a gear with a electro engine, and it just moves the parallel kinematics. But it's very important to know to each moment exactly the position of the motor. And in the end of the wings, we have 2 servo motors as well, and they give an active torsion of the wings. Also, this has to be very well synchronized. Otherwise, it's just not efficient, or we would not be able to fly curves, for example. So it was very, very important to have an intelligent monitoring and to have a lot of decentralized control on board of the bird. And this is something we have in many times in industrial automation as well. So we really learn from nature doing these kind of demonstrators and try to transfer the knowledge to our development and research departments so that we get these innovative stuff in our products as fast as possible.
And you turn into something tangible that you can feel and experience and actually test, right? These things that you've learned.
So, and for you guys, we brought one smart bird with us. It flew the long way from Germany to here. Only one battery.
This is Frida, our test pilot.
If you want to see how it really flies, you want to see? Maybe could we switch a little bit to the light condition that our pilot can see something? Okay, perfect. Perfect. Thank you very much.
That's fantastic. That's really, really
Thank
cool.
Thank you.
And a lot of really neat things about this. I mean, it really flies like a bird. Like I just learned this morning, it steers not only with the tail, but its head like a real bird does. And it's such a light design. So it's light and strong. And again, there's all these lessons from nature. I mean, it's powered, again, I saw it last night, just a little cell phone battery. There's enough energy to power this thing for actually a much longer duration than we just watched. It's just great design. And we got a lot of the lessons from nature. So, fantastic work. Elias, Frida, thank you very much.
Thank you.
Elias, thank you very much for joining us. Elias only scratched the surface on all the cool projects that they work on at the Bionic Learning Network at Festo. So if you want to see more of those projects, go to festo.com/bionic and check it out. It's really cool stuff. And I understand in April?
Yes,
in
April, 7th of April, the new project developments are presented on the Hanover Fair in Germany and on YouTube as well.
So more cool stuff to come from the Bionic group. So that's really awesome. So again, thank you very much.
Thank you very much. Bye.
Everyone. Oh, thank you. Okay. I hope everyone had a great morning. A lot of great stuff. The work done by Festo and VJ, really, really cool things. Have an awesome afternoon today. Learn a lot at the sessions, meet a lot of other SolidWorks users, and this evening we're going to have a great time at Islands of Adventure at the event this evening. Okay? So have a great afternoon, everyone.